One of the darkest periods of British rule over India was 1943, when the Bengal Famine struck. An estimated 20 to 30 lakh men, women and children died of starvation and disease. This was a result of a colonial power whose only motivation was to exploit India economically. Even though India was an agrarian economy, there were virtually no investments made in agriculture by the British, be it universities for human resources, research institutions for developing better varieties of food grain and vegetables, or large-scale agricultural infrastructure like irrigation projects from dams to canals. As a result, hunger, poverty and malnutrition abounded in India.
There was a question of recurrent droughts and famines. It was not just famine because of exports of food to Britain. Like, for instance, during the Bengal famine, you know that about 50% of Britain's grain and wheat flour, imports were coming from India. So there is a way in which the colonial government handled these exports, and there was nothing that we could do about it as a nation state at that time.
By the time the British left in 1947, India's agrarian-dependent economy was on the brink. Post-independence, the government prioritized development of scientific agriculture. Emphasis was laid on the related ecosystem of agricultural production, from setting up of large fertilizer and pesticide plants, building multi-purpose irrigation and power projects, and importantly, emphasis was put on starting agricultural universities, setting up postgraduate schools like the Indian Agricultural Research Institute, which was established in 1958, as well as new agricultural research institutions for important food crops like Central Rice Research Institute at Cuttack and Central Potato Research Institute, Simla. These were steps that eventually led to India's Green Revolution. So in this special series of Science for a Self-Reliant India, we take a close look at India's Green Revolution that transformed us from a nation which was a net importer of food grain to one with a surplus.
In spite of the fact that we could apply fertilizer and do more irrigation, we found in the late 1950s our then cultivated varieties of wheat, rice and other crops did not respond to good soil fertility or irrigation water. This is because they had a kind of plant architecture which made them fall down when more nutrients were given. This is where the search for new genes, the non-dwarfing genes, occurred.
Watch the fascinating journey of India's agricultural transformation only on India Science. In 1947, when India gained independence, 72% of the working population was engaged in agriculture. So it was imperative for the Indian government to focus on the agricultural sector to improve the economic condition and to remove the scourge of extreme poverty, hunger and malnutrition. India turned to science and technology to find solutions to these pressing problems. This included augmenting agricultural infrastructure like research and educational institutions, increasing the supply of seeds, providing credit, fertilizers and pesticides to farmers. But these initiatives and policies were time-consuming, and given India's expanse, would take time to transform agriculture. So food security was still a challenge to be overcome. India's population after independence began to increase by over 3% as there were advancements in the public healthcare systems. But even with impetus given to agricultural food production by the government, we could not keep pace with increasing consumption in the 1950s. We became dependent on the United States for imports of agricultural commodities, which began in 1954 under a program called PL 480 and lasted till 1971. But coincidentally, the year 1954, when PL 480 started, was also when Dr. M.S. Swaminathan a young scientist who would go on to play a crucial role in transforming Indian agriculture, returned to India from the United States. Dr. Swaminathan, who is 96 years of age, started his career as an agricultural scientist in 1947, the year of Indian independence, when he moved to the Indian Agricultural Research Institute in New Delhi as a postgraduate student in genetics and plant breeding. With a fellowship from UNESCO, he continued his research in the Netherlands and earned his PhD from Cambridge University. He then moved to the University of Wisconsin, USA, to help set up the United States Department of Agriculture's Potato Research Station. A true patriot, Dr. Swaminathan returned to India in 1954 with the determination of improving agricultural production and contributing towards India's food security by leveraging the latest scientific techniques. This was a time when the Indian government was working to find ways to drastically increase agricultural output. The agricultural strategy in the 1950s was to enhance agricultural infrastructure, which included intensive irrigation and providing farmers with chemical fertilizers and pesticides, particularly for wheat and rice. But the agricultural scientists found that this approach was not giving the desired success.
In spite of the fact that we could apply fertilizer and give more irrigation, we found in the late 1950s our then cultivated varieties of wheat, rice and other crops did not respond to good soil fertility or irrigation water. This is because they had a kind of plant architecture which made them fall down when more nutrients were given. This is where the search for new genes, the non-dwarfing genes, occurred. I wrote to Norman Burlog in the early 1960s, requesting him to both send some material of the new dwarf varieties as well as visit India. At my request, he also sent bulk quantities of seeds of 4 released varieties in Mexico: Lerma Rojo 64A, Sonora 63, Sonora 64, and Mayo 64. We immediately, as soon as the seeds arrived, split them into a number of parts, sent to Ludhiana, Kanpur, Pantnagar, Pusa, Indore, of course Delhi, for a multi-location testing. And all of them uniformly showed that the new dwarf varieties are capable of yielding 3 to 4 times more than the earlier tall varieties.
Dr. Norman E Burlog was an American microbiologist who started working as a geneticist and plant pathologist at the Cooperative Wheat Research and Production Program in Mexico. His work involved scientific research in genetics, plant breeding, among other related areas. Within 20 years of extensive research and experimentation, Dr. Burlog and his team were successful in finding high-yielding, short-strawed, disease-resistant wheat varieties, which eventually resulted in the Green Revolution in India and other parts of the world. Dr. Swaminathan, as advisor to the Ministry of Agriculture in the early 1960s, extended an invitation to Dr. Burlog to visit India as he had been following his research on wheat plants. Dr. Burlog's visit and his collaboration with Dr. Swaminathan, with the support of the Indian government and agricultural institutes in 1963, was the beginning of India's agricultural revolution. The two scientists worked side by side to develop wheat varieties that would yield higher levels of grain, as well as develop stalk structures strong enough to support the increased biomass of the plants.
So these in 61, a nursery called International Wheat Rust Nursery. It was obtained from USDA and it was brought to Indian Agriculture Research Institute, what we know as Pusa Institute, here on this campus, which is known as seat of Green Revolution. So while screening those set of lines, couple of hundred lines for rust reaction, rust is a disease caused by fungi. Our scientists here, they were able to identify some lines which were very dwarf in height. So they identified the potential of these dwarf lines in terms of enhancing productivity, and subsequently the request was made to USDA as to where from these dwarf lines have come. It was revealed that these originally came from Dr. Burlog's program. Dr. Burlog was invited, he came and saw, he also felt very happy. And then a team of 3 scientists, Dr. S.M. Sikka and Dr. S.P. Kohli and one plant pathologist, they went to Simit in 65-66 to see these lines and to see this seeds of these varieties can be brought. So ultimately, in 66-67, 18,000 tons of seed was imported of varieties like Larma Rojo, Sundara 64 and so on. And these were grown in the crop season of 66-67 in approximately 4 lakh hectare area. And the harvest that came from 68 crop a year later, because this was primarily used for seed multiplication. So 1968 we produced almost 18 million tons of wheat from 12 million tons. So there was a jump of almost 6 million tons in total wheat production, and we were importing about 10 million tons. Of that, 6 million tons was compensated by increased productivity, and this phase was described as Green Revolution by William S. Gould.
The American wheat varieties developed by Norman Burlog, an American agronomist, were tested for the first time in GB Pantnagar University of Agriculture and Technology. Locally adaptable selections like Pantnagar Kalyan Sona and other improved varieties were released for farmers. The university utilized its 16,000 acres of land to launch one of the largest seed production programs at that time under the brand name of Pantnagar Seeds, which then became a household name in rural India. The contribution of the university was recognized by Norman Burlog himself, who described Pantnagar as the harbinger of the Green Revolution. Norman Ernest Burlog's initiatives worldwide contributed to the extensive increase in agricultural production and led to what we now call as the Green Revolution.
That is where an entire research strategy that is built on, plant breeding sciences, which is built on what is called defensive research, pathology. Yeah, Norman Burlog himself, we celebrate him as a plant breeder, but he was a pathologist. He was not a plant breeder. But his research helps build this agenda of defensive research, which is again, build plants that are resistant to a range of, pests and diseases, right? So build its immunity to or resistance to certain things, or stress tolerance to, depends on the kind of defense. But that becomes the offensive research strategy once this Norin 10 comes in and you build this so-called short-statured, high panicle weight-bearing crop. Yeah, so you start breeding for that. The build-up of this offensive research strategy has implications for agricultural research in India too. We also shift from this, like I mentioned, a multiple, agency and multiple research agendas contributing to agricultural science and agricultural knowledge to one little, package-focused agricultural research.
Dr. Norman Burlog was awarded the Nobel Peace Prize in 1970 as the founder of the Green Revolution and his contribution in helping the world feed itself. After the success of the Green Revolution, Dr. Swaminathan went on to establish some of India's leading institutions like the National Bureau of Plant, Animal and Fish Genetic Resources of India and the International Plant Genetic Resources Institute. At 96, Dr. Swaminathan still works to empower the Indian farmer through the MS Swaminathan Research Foundation based in Chennai. While India's leading institutions like the Indian Council of Agricultural Research, ICAR, played a pivotal role in the success of the Green Revolution, there were other important institutions established in the 1950s and the 1960s that played a crucial role in the success story of Indian agriculture. In 1962, the Punjab Agricultural University was set up at Ludhiana. It is the third oldest agricultural university of India. The Punjab Agricultural University together with other research institutes of ICAR such as IARI, has played a pioneering role in ushering in the Green Revolution in most of North India, especially the Punjab region. Today, Punjab, with 1.53% geographical area, contributes about 60% wheat and 45% rice to the central food grain stock. This has become possible due to the path-breaking research at this university. PAU also produced the first hybrid grain pearl millet in the world. Presently, about 95% of the area under wheat and 60% of the area under rice in the state is under improved varieties recommended by the PAU. The PAU varieties have been popular in many other states of the country as well. Some rightly call it the mother of the Green Revolution. The university now has 4 constituent colleges, which include College of Agriculture, College of Agricultural Engineering and Technology, College of Home Science and College of Basic Science and Humanities. Similarly, other leading institutes were established to provide a thrust to agricultural research and teaching in the country. For example, the Central Rice Research Institute was set up at Cuttack in Odisha in 1946. Subsequently, in 1966, the administrative control of the institute was transferred to the Indian Council of Agricultural Research. Since then, it has been consistently engaged in state-of-the-art research in development and improvement of rice varieties in the country. The Central Potato Research Institute was established in 1949 at Patna and was later shifted to Simla, Himachal Pradesh in 1956. The aim behind the establishment of the institute was to facilitate hybridization work in potato breeding and to maintain seed potato health. So far, the institute has released a total of 50 high-yielding varieties of potato possessing a combination of important agronomic traits suitable for cultivation under diverse agroclimatic conditions.
We're talking about the 1950s where, well, like I mentioned, the first and second plans did a massive investment in infrastructure development. But in the sciences, the focus was not exclusively on rice and wheat. The food crops were given importance, but a lot of other food crops too. Yeah, the staples in India are still very diverse. Jackfruit is a raw staple food. Tapioca is a raw staple food. I mean, that is a staple food as in starch, right? Those were given importance and those were researched. So we talk about tuber crops like potatoes, research stations for them. You talk about a whole range of, MS Swaminathan's own PhD is in potato research, right? And he's a potato breeder. So there are people who've done really good work, who came back from the US and worked in India. So 1950s is actually a rich period where a lot of things happened, multiple research into food crops, not just into rice and wheat, focus on dryland food crops too, yeah, like maize, bajra, a big crop, sorghum, a big crop in the drylands, in parallel, a massive investment from the Union government on irrigation and irrigated crops like rice and wheat.
As a result of the work of such institutions and many more which were established subsequently, the 70s decade and afterwards witnessed a considerable increase in food grain production in the country. With an increase in the wheat yield per unit area, the country became self-sufficient in wheat production. India is currently the world's second largest producer of wheat. The success of the Green Revolution in India was a result of a combination of factors like enhanced water supply and fertilizers, because high-yielding variety crops need sufficient water for irrigation throughout the year. So the irrigation infrastructure, which was built in the 1950s and the 60s, like massive dams, water reservoirs, and networks of canals like the Bhakra Nangal project, played a crucial role in increasing agricultural output and eventually making India self-reliant in food production. The Green Revolution was in turn made possible as a result of enhanced water availability. This was facilitated by dams and water reservoirs, which in turn were connected to vast networks of canals. Dams proved to be a real boon for the agricultural sector, as the water needed to irrigate new crop varieties made farmers less dependent on the monsoons. Immediately after independence, dams became a prime focus of policy planners. Engineers and dam builders were given the task of building these massive structures. Two dam projects of the 1940s, 50s and 60s which stand out even today are the Bhakra Nangal project on the Satluj River in Punjab, now in Himachal Pradesh, and the Nagar Arjuna Sagar Dam on the Krishna River in Andhra Pradesh, now in Telangana.
There was a lot of support. This happened only because of strong support of policymakers, of scientists, and this complete symphony, what Dr. Swaminathan describes as, resulted into this change. But along with this, other inputs, because these varieties were highly input responsive, so you had to give them fertilizer, you had to give them water. So you had to arrange these inputs for better realization of the potential, and that is why the irrigation potential, which was hardly about 16%, and today we have got 65% area under irrigation, and the created potential for irrigation is almost 90%.
The Bhakra Nangal multipurpose dam were amongst the earliest river valley development schemes undertaken by independent India, which in turn helped to transform the agricultural as well as economic condition of the country. While the project had been conceived before independence, it was only after 1948 that specifications were finalized by India's leading engineers and policy planners. Two eminent engineers, Dr. A.N. Khosla and Kanwar Sen, impressed upon the Government of India to undertake the construction of the dam through the Public Works Department rather than hand it over to an external country or company. But they did recommend the role of international experts for design and guidance, because such a complex multi-purpose dam project had never been undertaken in India. The revised designs and specifications were entrusted to the International Company Incorporated, USA, through an agreement dated 14th November 1948 between the Irrigation Branch of the Public Works Department of Punjab and International Company Incorporated, USA. In 1951, a revised project report was prepared for the 207.26 meters or 680 feet high straight gravity dam. The Bhakra Nangal project started to take shape as a multi-purpose project comprising of the Bhakra Dam and power plants, Nangal Dam, Nangal Hydel Channel, Ganguwal Kotla powerhouses on the Nangal Hydel Channel, and a whole network of associated infrastructure and canals. The dam stands at 226 meters or 741 feet and is one of the highest gravity dams in the world, while the 166 square kilometer Gobind Sagar Reservoir is the third largest in India. It was also decided by the planners that the funds and efforts be concentrated on the early completion of the canal system, so that non-perennial supply of water might be available to the farmers as early as possible. The quick implementation of this policy resulted in the completion of the Bhakra Canal system, which in turn helped usher in the Green Revolution. The canals were inaugurated by the first Prime Minister of India, Pandit Jawaharlal Nehru, on 7th July 1954. 8 years after the project was started, Pandit Nehru dedicated the first phase of the completion of the dam on 22nd October 1963. Bhakra Nangal project stands to this day as a true multi-purpose project built by Indians shortly after independence, a true testimony of grit and determination of a young nation to overcome all odds. The road from 1947 to the Green Revolution in the late 1960s was a period when India adopted modern agricultural research methods and technologies to increase productivity. This included the use of high-yielding variety seeds, tractors, enhanced irrigation, pesticides and fertilizers. It also saw advancement of agricultural research and education. The strengthening and creation of institutions for providing farmers with marketing opportunities and better prices for their produce. Importantly, the scientific movement, which was embraced by millions of farmers across India, established the role of science and technology to improve India's economic fortunes and transform the country into a nation which is Atmanirbhar in food production. That's all in this episode of Science for a Self-Reliant India.